Okay, so the previous video got clipped because it was too long. So continuing, we wrote a polygon class. We want to now design a star class as a child of the polygon class. Okay, so let's start with cutting and pasting. Let's figure out what this is, right? Okay, so notice that first for a star, if a star has 5 spikes, 1, 2, 3, 4, 5, then the polygon has 10 points. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Likewise, for any star, this star has 6 spikes. 1, 2, 3, 4, 5, 6. How many points in all does the polygon have? Starting from here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right. So now we want to figure out a list of points here. So I have a small diagram here. If I have a 4 spiked star, it has 8 points, right? Starting from here, 1, 2, 3, 4, 5, 6, 7, 8. All right. So what is the angle for each point? Angle for each point is 2 pi over total number of points. Why 2 pi? Because angle of an entire circle is 2 pi. What is the number of points? Number of points is 2 times number of spikes. So angle of each point is 2 pi over 2 times number of spikes. Now when you reduce the 2's, you get angle for each point to be pi over number of spikes. Okay. Why is this angle important? From trigonometry, you know x coordinate of a point is radius times cosine theta, y coordinate is radius times sine theta. Okay, where if this is your circle, any point on the circle is given by x coordinate r cosine theta, y coordinate r sine theta. And this is true if the center is 0, 0, if the center is origin. If the center is somewhere else, then you have to shift the entire picture somewhere else. Shifting happens by adding to the x coordinate and y coordinate the appropriate amount. What is the appropriate amount? You need to add the x coordinate of the center to x coordinate of the point on the circle, y coordinate of the circle to the y coordinate of the point on the circle. So this is how you determine points which will define your polygon. So going back to our definition of your child class star, its instantiator should take number of spikes, should take outer radius, should take a center, should take a canvas, should take a color, and if there is no color given to it, the default color is red. Okay, how do we address any of these? Formal canvas, color, and you have an empty list. Well, use the polygon to polygon class that we defined to handle the list, empty list. As of now, you don't have a list. Okay, and then number of spikes. This is an this is additional information. Outer radius is additional information for a star. Center is also an important additional information. And points list, you don't have points. Nobody gave you points. They gave you number of spikes. So you need, your definition of the class needs to have a method or a function to be able to create points. So this method is called make points list. So the definition of this method is, well, a priori your set of points, list of points is empty. Notice points is a local variable. So it is not going to be used anywhere else. It's only for this function. So it's fine to leave it local. Angle is another local variable. Radius is another local variable. So what is the angle? Angle is pi over number of spikes. Radius is the outer radius to begin with. All right. Points in the beginning it's empty. Now you want to create 2 times number of spikes points. So you're going through a for loop in the range 2 times self dot number of spikes. Okay. X coordinate is, let's go back to our formula, center x plus r cosine theta. So self dot center 0. 0 means the first entry or index 0 item, which is the x coordinate, plus radius times cosine of your angle. I stands for the number of the point. For the 0th point, no cosine, no angle. For the first point will be 1 times angle, second point 2 times angle, and that's how you go around the circle. Likewise, y is center, y coordinate minus, y minus, because in mathematics y coordinate goes up, but in computer science graphics y coordinate goes down. That's why you have a minus there. You have created a point xy, append it to your list points. Now radius has to alternate. Do you see? This point gets outer radius, this point gets inner radius, next point gets outer radius, the one after gets inner radius, and so on. So if you are an outer radius point, so your radius is outer radius, then you have to decrease your radius. So we have we have changed our radius to half or 0.5 times the previous radius. If this my radius is not outer radius, that is the else part, then it's already an inner radius. So I need to call it outer radius now. I need to assign it outer radius. And at the end of this method, return the list of points. These points will be used to draw your polygon. So let's go back and let's create a star. Okay, let's create a star and let's try to draw it. There is one thing though, one tends to forget these things, and that is, let's look at the functions we have. We have cosine, sine, and pi. These don't come from, these are not easily available. You need to import them from math. So you need to have from math import these functions. All right. So now play with this. Okay. There was my initial polygon, and here is my star. Notice I did not give my star any color, so by default it is red. So let me give it, say, green color and run it. Now I have a green star. Let me move the center somewhere else. Instead of 200, 200, let's move it to 300, 300. I don't like 6 spikes. Say I wanted 15 spikes. I got that. Let me increase the radius to 100. I got that. So continue playing, okay? Outer radius is 100 pixels and so on. Until the next one. Bye.